Alright, I will be doing this question 2.3. It reads as follows. It says a beam is 16-meter long and has a mass of evenly distributed weight of 3000 Newton. The beam carries two concentrated loads of 70 and 100, which are 2 meter and 5 meter from the left end respectively. The two supports are placed at the ends of the beam. A distributed load of 15 Newton per meter is placed over the last 6 meter of the right hand side of the beam. So let me just try to draw the diagram. So this is our diagram. Then you are told that you have saying that you are being told that you have a distributed weight, right? And remember, it is in Newton, which is 3000. By so means they trying to tell you that this distributed load, it is distributed to the whole beam, right? It is distributed to the whole beam. You understand? So since it is given in weight, it is not Newton per meter. It is distributed along this 16. So it will be placed along here as a half of 16. At this part it will be 8, and this part it will be 8 meter, because it is distributed to the whole beam. You understand that one? Then the distributed weight like this, right? Then you are told that it is 3000 Newton, right? So that means from this part it will be 8, and this part it will be also 8. That means our remaining part is only this one, which it will be 2 meter. So if you check the beam, it will be on the center, this distributed weight, right? So I just forgot to mention this one. They said it's a distributed load of how much? Of 15 Newton per meter, right? And let us convert this distributed load into a concentrated load. So as we convert to a concentrated load, it will be 15 multiplied by 6, which gives us 90 Newton, right? Yes, meter. That means we are going to have this part, it will be 3, and this part it will also be 3, right? So like this, it will be 3 and 3. Just bear in mind that as it cuts here, this part it is 3, and this part it is also 3, but I cannot write that one. So in terms of calculation, we say the sum of clockwise moment equals to the sum of anti-clockwise moment, right? And moment about R, this one. Let us take moment about this one, right? I will just write R, moment about R. Then we say the sum of clockwise equals to the sum of anti-clockwise moment, right? As we can see from our diagram, the forces that are going to the clockwise direction, it's only L, this one, L only, you see, as it pushes up, it makes this beam to rotate on a clockwise direction, you understand? So it is L multiply, excuse, my marker is not working very well, then the total distance of this beam, which is 16, right? So this one is L, by the way, which is equals to the sum of anti-clockwise. This one is our first one, and this one is the second one, and this one is the third one, and this one is the fourth one, as they work on the clockwise direction, right? So let me just take so we proceed to say the first one, which is 90 multiplied by the distance from this part to the R support, which is 3. Remember, I said this part it will be 3 and this part it will be 3, as it bisects the total distance that it was distributed upon. So it will be 90 multiplied by 3. Then we say plus. This one is our second one, which is 3000 multiplied by the distance from this point to the R support, which is 8. You will get the point. It's 6 plus this 2, which is 8, right? Multiplied by we say plus, open bracket, the second one, which is this one, 100 multiply by the distance from this one, which is 8 from here plus 5. The mistake is not 8 plus 5, as this 5, it occupies this whole part, you see. I just made a mistake of that mentioning. It occupies this whole part, you see. It's 6 plus this 5, you understand, to give us 11. Yes, I just made a mistake, I'm sorry for that. Then we say multiply by 11, close bracket, close bracket. Then we say again plus this one, which is 70 multiply by this whole distance from this part to the R support, which is 14, right? Sorry for that, my marker is not working very well. Then we just punch on the calculator. This part we are going to have, let me use another pen. We are going to have 16L equals to, when you punch this on a calculator, you get what? You get 2, 6, 2, 6, 3, 5. Let me just try to be accurate. All right, then it is 26, 3, 5, 0 divided by 16. Divide by 16. Divide by 16. Divide by 16. Then our L becomes what? L equals to 1, 6, 4, 6, 8, 7, 5. Right, 7, 5. Newton, in terms of kilonewton, you divide by 1000, which is, it becomes 1.646. This is 6, right? 6 kilo newton. Yeah, kilonewton. But if you are not asked to write in kilonewton, your final answer becomes this one. So coming to the next one, you just do the same. You take moment about L, and when done that, we're taking moment about R. Yeah, you take moment about L to calculate the value of R, right? And you just perform the same calculations as I did here. So I cannot repeat this calculation for the value of I will just write this. I will just make a shortcut to find the value of R, right? As you know, the upward forces equals to the downward forces. The sum of these, they are equal. So I will just make the shortcut, but in terms of calculation in exam, just do the long calculation, because if you can use this one to find the other part, you can mark it wrong if the first support you got it wrong, because this one, it only depends on the first support that you got. If this one is wrong, that means this part, it will also be wrong. So just try to use this method, the sum of whatever, so that you can be accurate at least. Let me just write my value here. As L, I said, is what? It's L, it's equals to 4, 6, comma, 8, 7, 5. 7.5, right? Newton. So let me use the method of sum of upwards and downwards just in case, but you will use this one as you go. I'm going to add the sum of forces that are going down and this one. I'm going to add them. So it is 90 plus 3000 plus 100 I'm sorry because of that mouse is not working very well, and 70 when I add this I get 90 let me just take this part out. 3 2 26 260. This is 6, right? Newton. This is Newton. Let me take out. Then this is our forces that are going down, right? So equals to the forces that are going up. So it is 3 2 6 0 equals to the sum of forces that are going up, which is this one, 6 1 6 I mean 4 6, this one is 4 6 comma 8 7 5 plus R. So you take this one to the other side, you take it to this side, so it becomes this one minus this one. Therefore R equals to, when you punch on a calculator, you get 1613 comma, this is 1 comma 1 2 5 Newton. This is your R value. So when you add these forces, they must be equal. The force of going up and the force of going down, they must be equal. So that's it. Just to avoid to use this method of sum of going up and sum of going down to find the other support, just in case